We're going to use each of the shortcuts that we learned for sine and cosine, and this will work only for sine and cosine, to create an overall shortcut for graphing these quickly. And it's often on the final exam that when these are asked to graph, they have all four, A, B, C, and D combined, and you have to graph them all. So doing our old technique of showing where each of the 5 points would go would take too long. The shortcut I call DAB C. Has a nice ring to it. And the reason it's called DAB C, because when you're graphing, remember when you normally graph, you would do all of your stretches and compressions first, A and B, and then you would do C and D last. But in the shortcut, due to the properties of sine and cosine, we can actually start with B. So our order is a little bit different. And the very first thing you're going to do in DAB C is draw your sinusoidal axes. Because your center line started at 0, can you see that multiplying and dividing would keep your center line at 0 no matter what? So that's why you're allowed to start with it by moving up and down, because the multiplying and dividing actually don't affect it. Then you can go to your A value, which is your amplitude. And remember, the definition of your amplitude is the distance from your center line to a maximum or a center line to a minimum. So now that we've got our center line, our sinusoidal axis, we can use our amplitude to go up and find our maximum and go down and find our minimum. Next, our B value found our period, because our B value is a horizontal stretch or compression. So we use our B value, and we can write a little formula for our period. Our period is always going to be 2 pi divided by our B value. That formula is not on your formula sheet, but it's super helpful, so I would say probably going to have it memorized before too long. So if the period is 2 pi over B value, what do? We label that period and break it up into 4 equal sections. If I scroll down to the B, is everybody there or not yet? Okay, I know, I want to go too fast. Oh, wait. The dash actually means something in DAB C. So what you do is after you've done the DAB, then you graph everything with a dotted line. So the dash means graph it with a dotted line without the phase shift. So you can get an idea what it would look like without a shift. Because our shortcut for the shift was draw the original and then just shift everything over a little bit. So we do the DAB part, which gives us a whole bunch of information, but then we draw it without the shift, which then allows us to do the C part, where we can translate our graph either left or right. So in tomorrow's class, we are going to do a bunch of examples with all of the things and practice using the DAB C.